Hi, this is problem 15 from the 2024 AMC 10A. Let m be the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the units digit of m? So right off the bat, I see an opportunity to form a difference of squares that I can factor, and that's usually helpful in solving integer equations, so let's try that path. So we have this larger square, let's call that b squared. Smaller square, let's call that a squared. Take the difference to form b squared minus a squared. M's cancel. We're left with 2560. That's a handy number. 256 is 2 to the 8th. So we can factor this pretty quickly. And of course we can factor the difference of squares. Sum term, difference term. Now the idea is we want to split this number into a factor pair and then extract the values for b and a in such a way that maximizes m. So to maximize m, we have to maximize both a squared and b squared. So it seems as though we have to maximize this first factor in our pair, b plus a. So as a first cut, why don't we take this whole number and throw it into the first term, leaving a 1 for the second term. Now to extract the value of b, we can take the sum of these factors to cancel the a, divide by 2. And when we do that, we notice that we end up with a non-integer value for b. So it turns out this is not a valid factor pair construction to give integer solutions. So as a second cut, why don't we try to move a factor of 2 over to the second term and extract the value of b in the same way. Add these two factors, divide by 2. To extract a, we take the difference of the two factors, divide by 2. Okay, that's a good start. Let's try to move another factor of 2 just to see how this works. So shifting another factor of 2 over to the second factor, we can extract b in the same way. Add them, divide by 2. Subtract them, divide by 2. To find that as we shift more factors over to the difference term, these numbers that we get for a and b are going to get smaller. That goes in the opposite direction that we're trying to achieve. So the case that maximizes m is this second case here. And now we can use the value of a to calculate m. Now since we're only trying to find the units digit of m, we can take a calculation shortcut. We know that 2 to the 7th is 128. If we multiply that by 5, we end up with a number that ends in the digit 0. And if we subtract 1, we'll have a number that ends in 9. So we know then that a is equal to something that ends in 9. So a squared is now something that ends in a 1. And from that, we want to subtract 1213 to compute m. So 1213 we want to subtract to form m, which is then a number that we know will end in 8. And so the units digit of m is 8 for choice E.